Okay, what we're going to look at today is solving equations using either multiplication or division. And these are single step. We're going to do them a lot like we did the addition and subtraction ones. Should be okay with it. First step is, remember, there's two sides to the equation. So I'm going to want students to put a line down just like this so we separate the two sides of the equation. Here's one side, here's the other side. The equal sign is what separates it. It's like a balance scale, okay? And we want to keep it balanced, so whatever we do to one side, we need to do the same thing to the other side. Okay, so on this problem now, we want to get C isolated, get it all by itself. So we need to look at what's being done to C. Well, C is being multiplied by 5. So we need to undo that, okay, or do the inverse operation, which is to divide by 5. We'll get rid of this 5. So we show it like this with a fraction bar to show divide by 5. We got to go over to the other side and do exactly the same, divide by 5. Okay, these 5's cancel out, all right? And if you think of it, this ends up being like a 1 and 1, so you end up getting here 1C over 1. Okay, well, that is whatever C is. Okay, for example, if let's say that C was 10 here, okay, 10 times 1 is 10, 10 divided by 1 is 10. So those 1's can be totally eliminated, and it's just C that would be left here. So we don't need to put those 1's in there, we can just cross those 5's out, and C is the only thing left. So C equals negative 65 divided by 5. Now you got to think back to the rules of integers here. We're dividing a negative divided by a positive. So our answer is going to be negative, okay? And you know, depending on your ability to divide, if you have to use a calculator, that's certainly appropriate. So on this one right here, we're going to end up with our answer being negative 13. Okay? Let's go to number 2 now. All right, similar problem. The only thing different here is our variables on the right side. That's okay. Leave it there. Okay, so we'll divide it into 2 parts again. This is one side. This is the other side. Okay, we want to get rid of the 7 and negative 7, so we got to divide by negative 7. So we divide both sides by negative 7. The 7's cancel. We're left with m over here equals, now negative 42 divided by negative 7, that's positive 6. Okay, and remember, you can always check your work. We're saying our answer is positive 6, so we can put it in here. Negative 7 times 6 is negative 42, so it does check out. Back to this one here, we can check it also by putting negative 13 in. Negative 13 times 5 is negative 65. So it is a good idea to check work. Okay, let's take a look at a few more here. All right, here is a number 3 from the textbook. Now we want to get rid of our 8. Okay, it's 8 times p, so we're going to divide by 8. Divide by 8. We show it again with that fraction bar. These 8's cancel, so cancel it out. P equals 96 divided by 8, which is going to be 12. Okay? And we can check it. Put 12 in here. 12 times 8 is 96. All right, number 4. A little different look to this one. Okay, but we start at the same. Okay, getting our 2 sides to our equation here. We want to get rid of our 12 now, so we get n all by itself. Now, here's what you got to ask yourself. What is being done to n? N is being divided by 12. Okay, that fraction bar indicates division. So what we need to do is the inverse operation or undo division by multiplying. So we need to multiply both sides by 12. That will get rid of this 12. So we're going to show it like this. I'm just going to put a dot to show multiplication. I'm going to multiply by 12. I got to go over on this side and do the same thing. I'll show it just like this, multiply by 12. Okay, these 12's would cancel out. Okay, it would look like this right here. Okay, you'd have, that's what you'd look, if you're multiplying by 12, this is how it would look. So when you reduce here, you get 12 goes into 12 once, 12 goes into 12 once. So when you multiply this, you get 1n over 1. And that goes back to the problem number 1 that we did. That's whatever n is then. Okay, so we don't need all these other numbers here, so our answer is going to be n. So n equals 12 times 12, which in this case is 144. Okay, now, if we put 144 in here, 8 times 144 does, I'm sorry, right here. We put 144 in for n. 144 divided by 12 does equal 12, so it should check out as well. Okay, let's take a look at another one. Let's see here, clone this page. All right, now this one a little different look, t divided by -2. Okay, so we set it up the same way. Okay, we want to get rid of the divided by -2, so the inverse operation is to times by -2. We need to do that on both sides. Okay, these cancel. All right, so I have t left over here, and -2 times 18, okay, and that's going to be -36. Now check your work, so put -36 in here. -36 divided by -2 is +18, so it does check out. All right, here's one with the decimal. All right, so once again, we're going to set it up like this. We want to get rid of the 0.6 times h. We want to get rid of the 0.6, so I divide by 0.6. Go over here, divide by 0.6. These cancel, so h equals 1.8 divided by 0.6, okay? And if you were doing this, you would set it up like this with your, if you did a long division. You know, you can use a calculator, so that might be easier, but I move my decimal one place, move it one place, bring it straight up, and my answer there is going to be 3. Okay, so this comes out to 3 here. And then you can check your work. 3 times 0.6 is going to be 1.8. So h is 3 on that problem. Okay. Those we already did. Okay, here's number 7 and 8 from the book. Clone the page. All right. Similar problem here. Okay, we're going to divide both sides by 0.4 because we want to get j by itself. So I need to get rid of that 0.4. Okay, these cancel. So j equals -3.4 divided by 0.4. Now a negative divided by a positive is going to be a negative answer, so I know my answer is going to be negative. Once again, if I set this up, 3.4 goes inside the box of a long division problem, 0.4 here. Remember, we move this decimal one place, move this decimal one place, and bring it straight up. Okay, now 4 goes into the 34 8 times. We get 32 here. All right, if I subtract, I get 2. I add a 0, bring it straight down. 4 goes into 20 5 times. And there's my answer. And I already determined it's going to be negative because I got a negative divided by a positive. So negative 8.5 is my answer on this problem. I'll circle it because it's a little messy there. Okay, last one we're going to look at here. This one is certainly the most challenging of the bunch we've looked at. And what we have going on here is we need to get rid of this -3/4 because we want to get k by itself. Okay, now, to get rid of a -3/4, we got to multiply by its reciprocal. So we got to multiply by -4/3. Watch what happens when we do that. If we multiply by -4/3, okay, I'm going to do the same thing over here. Multiply by -4/3. All right, these all come out to 1 and 1 and 1. So we end up here with 1k over 1. And like we talked about earlier, that's whatever k is then. So we don't need to write that. We can just write k down. It canceled it out. It canceled out the -3/4. So I'm just left with k. Now I got to get this correct right here because this will be my answer. I'm going to put my 12 over 1. Okay, now I'm going to do some cross-reducing here. And this is something we did earlier, so this isn't new. 3 goes into 3 once. 3 goes into 12 4 times. There's no other cross-reducing I can do, so I have 4 times -4. 4 times -4 is 16, and it would be over 1, so negative 16 would be my answer. Now you can take that and put it in here and make sure that it checks out. A negative times a negative is a positive, so that part of it checks out. You know, then you gotta crunch the numbers to make sure that it's really gonna work. But you could probably do that in your head. 3 times 16, okay, is 48, and then 48 divided by 4 is 12. So it does check out number-wise. So that's how those have to look. Good luck.